welcome the next speaker, which is Dean Lee. Dean has over 25 years of experience in test and measurement, especially in characterizing and validating the performance of carrier class routers and switches. He's currently the Director of Product Management at Ixia, overseeing the Layer 2, Layer 3 test products portfolio. Prior to Ixia, Dean Lee has worked for HP and Agilent as a system engineering, sales manager, and business development manager. He is a top expert in L2 and Layer 3 networking and routing protocol testing, including protocols like OSPF, BGP, IPv6, MPLS, VPN, data center networking, carrier Ethernet, and SDN. Dean Lee also holds 2 patents in designing the best quality of service and network convergence measurement techniques, and he received the MSEE degree for New Jersey Institute of Technology. So please let me welcome Dean Lee to make his presentation.
All right, thank you for the introductions. I realize this is the last presentation before lunch, so I'll make it quick so we can all ready for lunch.
Actually, you have 45 minutes.
Oh, really? Don't worry, this is not going to be a long presentation. Okay, so this is the agenda for today. We're going to talk about the motivations and need for benchmark testing. And also, I would like to share with you the ongoing effort within IETF, especially for the BGP convergence benchmark testing. And also with the help from Rajiv at Huawei and Bhavani from Cisco, we put together several test cases based on the BGP test methodology currently working in IETF. And we have a pretty good test results and key observation I'd like to share with audience today. So why do we need the benchmark testing? Right? Benchmark tests provide a unified and creditable test methodology which can be repeated with consistent test results. It can easily allow users to compare different networking platforms. And also with the convincing and easy to read test score. And the end goal is to remove any kind of ambiguity in terms of terminology and test method, and eventually avoid apple and orange comparisons. As everybody understands, BGP is the most widely used protocol in carriers network today. Right? It's very critical for faster BGP routing table convergence. And especially the impact on these routing convergence has a direct impact on customer service level agreements. The validation and characterizations of BGP speaker is paramount to determine network reliability and availability. Right? So currently, IETF BNWG has ongoing effort to standardize the testing of BGP convergence. This table summarizes many different services and applications supported by BGP today. BGP is widely used to advertise the reachability of IPv4, IPv6, unicast, multicast routes, Layer 3 MPLS VPN routes, even Layer 2 MPLS pseudowire, VPLS LAN services. And not to mention, you can even use BGP to advertise Layer 2 MAC addresses for ECMP reachability to interconnect data center. In addition, BGP can be used to advertise IP routes with MPLS label for inter-AS domain connections, as defined in RFC 3107. So there are many, many different applications. BGP pretty much the most favorable protocol for any carrier today. And lastly, BGP can be considered as an enabling protocol to support SDN. I think we have heard several presentations yesterday and today, and you can see, BGP continue to be one of the top choice. So currently within IETF BMWG, there's one RSC 4098 already published to standardize the terminology for benchmarking BGP device convergence. Right? And there are ongoing effort. There are two BGP drafts for benchmark testing, draft Papneja and draft Varlashkin. The next slides will summarize the differences and objective of these two drafts. Okay, so this is a very busy table. I'll just give you a quick summary. Draft Papneja, the one on the left, assume the forwarding ability equal a full protocol convergence, while draft Varlashkin assuming forwarding ability is independent of control plane convergence. Right? So it needs to be tested separately. In terms of measurements, draft Papneja assume the data plane measurement to determine the BGP convergence. And draft Varlashkin basically assume the data plane forwarding and the control plane convergence, they are separate, they could be independent. And especially the modern router, they have many different secret sauce, special algorithm built in. When convergence happen, the data plane sometimes can go ahead even before a full convergence in the control plane. And this is quite common to achieve a much faster convergence time. Right? In terms of the test setup, draft Varlashkin has additional IGP, a scalable IGP to increase the background loading to BGP routing table. Right? And the next two rows that basically lists all the defined convergence tests and also failure scenario defined by these two drafts. You probably cannot see it from the back, but I'm just going to read a few key ones for you. Like in terms of failure scenarios, we can do local and remote link failure. That's a very common test. BGP, session failure. BGP hard reset, soft reset. That's another popular scenario for carrier. BGP route withdrawal, and also change of path attributes and graceful restart. Right? So now I'm going to show you the test results we have gathered, and especially preparation for this conference. Actually, I'm going to show you three tests: rip in, rip out, and attribute change convergence. And the DUT is a black box. I won't tell you which vendor is that. So you can see the result. Maybe you can figure it out. And it's a PE router. So it's acting as an MPLS IP PE router. And this DUT is surrounded by test tool. We have multiple test ports connected with the DUT. And the test port is quite capable to emulate a very large topology. Could be, it can simulate many different CE router. It can simulate P and PE to make up the entire layer 3 MPLS VPN. And with the advancement of these test tools, it can do a lot of things. These test ports can generate and analyze test packet, with a very super high accuracy. Right? So you can calculate throughput, latency, major packet loss. And also you can capture packet, especially the BGP control packet, with the very precise timestamps. So we can evaluate, many different things as part of the testing. And most importantly, especially with the advancement of this measuring technique, the test tool nowadays can even automatically measure convergence time. and based on a couple of different methodologies. One of the most popular one used by the industry today is measuring the convergence based on the number of packets lost, right? So test tool can automatically calculate how many packets disappear during the convergence and automatically report, into a time domain and tell you exactly what is your convergence time in milliseconds or seconds. That's one methodology. And the second methodology is quite unique as well. Test tool can also measure the convergence by monitoring the throughput on the incoming and outgoing ports, right? When convergence happen, you can see the data plane drop and data plane reconverge on the same port, or could be reconverged on the different measurement port. So by measuring when the throughput change at the very high precise moment, basically test tool will be high-speed sampling all the incoming frame per second. And we'll be able to capture exactly when the convergence happened and when the restoration completely finished. And that's your convergence time. And most importantly, it's part of the test methodology. You need to record when is the failure events. When did that actually happen, right? So that's a very important element to be part of your convergence calculations. So you need to be able to calculate, when is the BGP session flag? When is the change of your route attribute that caused the convergence? And when is the link going down? When somebody unplugged the cable, cut the cable, at what moment, when did that happen, right? So that is a very tricky part to measure. Right? We have visited many different carrier labs, and we have seen they do this measurement in many different ways. And some people even turn on the stopwatch and start clocking how many seconds it happened after they pull the cable. Right? I'm sure a lot of you are still doing that today. But with the advancement of test tool, these events happen that cause the convergence can be automatically recorded today with the ultra high resolution down to millisecond range. Right? So that make the measurement and automation, especially the automation of the testing, much more effective. Okay, so this slide lists the initial condition for the testing. I just kind of put it up here as a reference. And DUT is, as I mentioned earlier, is a PE device. And we use up to 3 test ports. And these test ports basically are used to emulate the CE router and also the remote PE and also CE routers. You'll be able to see this topology here. Let's see. Okay. So this is the first test, rip-in convergence. Right? So with this test, 2 test ports are used. And you can see the test port 1 emulate a CE router. And the CE router has eBGP session established with a DUT. DUT in this case is a PE1, a PE router. And then the second port is used to emulate a remote PE and also the remote VPN sites. Right? And the test objective of this one is to measure the convergence time required to receive and install a VPN route in RIP using multi-protocol BGP. Okay? So the test starts with CE1 send traffic toward VPN routes. In this case, PE1 doesn't know where to deliver this packet yet because it doesn't have the route installed in its RIP information base. Right? So we don't get any packet here. And PE2, step 2, PE2 in this case, at this moment, will advertise VPN route A toward PE1. And PE1 receive these route advertisement at receive route time. Right? So that's the first timestamp we'll be collecting. And at step 3,